sections. Conic sections can be defined as the intersections of planes or cones as the Greeks define them, as the graphs of the second degree equation ax squared plus bxy plus cx squared plus dx plus ex plus f equals 0, or as sets of all points satisfying specific geometric properties. Here are pictures of those intersections of cones and planes. Cones, here are two cones that are lined up with their points together, and basically if you take a line and a pole and rotated it around this point, this is the cone you would get, and then we take a plane, a flat surface. If it goes straight across, we can get a circle. If it goes as more at an angle, we'll get an ellipse. Here's a shape we're familiar with. It's the parabola, and that's the quadratic equations that we've dealt with before. If you have that plane pretty much go straight up and down through both edges of the cones, then you get what's known as a hyperbola. We're going to start with the circle. The equation for a circle is a minus h the quantity squared plus y minus k the quantity squared equals r squared. That's the standard form. The center of this circle is at the point hk, and the radius is r. So this is the standard form of the equation of a circle. If we start, and here we have to write the equation of the circle with the center at -3, 4, and radius of 5. Now remember, our standard form is x minus h the quantity squared plus y minus k the quantity squared equals r squared. So x minus -3, we'll turn it into plus 3, the quantity squared, plus y minus k, so y minus 4 squared equals 5 squared. Now we could multiply this all out, but they just asked the equation of a circle, so let's leave it in this form. We have the equation. We want to write it in standard form and locate its center and radius. Well, to do that, I'm going to group the x's and the y's together. We're actually going to do completing of the square. So I'll have x squared plus 4x, and then I'm going to leave a plus, a space, we complete that square, then plus my y squared minus 6y plus completing a space for completing the square equals, I'll add the 3 to both sides, so 3, and if I add these things to the left, I must add them to the right, so I'm going to leave space for those. Now you'll remember completing the square, we're looking for x minus h term here, squared. So to do that, here's our x, because this is a plus, it's plus, and half of 4 is 2. 2 squared is 4, and that's what I'm adding in both of these places. Now I go to the y term. I'm looking for my y minus k. So we'll want the quantity squared. Here's -6, so half of -6 is -3, and -3 squared is 9. So I have x plus 2, the quantity squared, plus y minus 3, the quantity squared, equals 3, 7, 16, which of course is 4 squared. So my center is at -2, 3, and the radius is 4. Next, we'll switch to the parabola. Parabola is a set of all the points in a plane that are equal distance from a fixed point called the focus and a fixed line called the directrix. Now this is a different definition of a parabola than we've had before. The midpoint between the focus and the directrix is called the vertex. And it's that here we're talking about the same vertex we did with quadratic equations. So here's my vertex, and they're saying this distance is equal to this distance. Or if I pick some other point on the parabola, this distance here would be the same as this distance here. The same number of lines across means they're equal. Well, we could even go to this point over here. This distance would be the same as this distance. The line that passes through the vertex and the focus is the axis of the parabola. We talked about axis before. I can draw it straight here. This one. This would be the line, the axis x equals h. Now, the standard equation for parabola with a vertex hk, and the focus is at h and k plus p for that going up. The directrix is y equals k minus p, so it's going down. So here's my k minus p. Here's the vertex, focus, directrix. So the equation is y equals a times x minus h quantity squared plus k. That's an equation we should be familiar with parabola. And a equals 1 divided by 4p is its x, where a, this a right here, is equal to 1 minus 4, 1 divided by 4 times p that we're talking here. Its axis is vertical, and the axis would be x equals h here, being that vertical axis, if I could draw straight. So x would equal h is the axis. Now, we can have a parabola that goes sideways, and we've talked about this before, but we didn't use them because it's still not a function. This still has its vertex at hk. Its focus now is at h plus p because it's going to the side, and directrix is at x equals h minus p. So it's still that same distance, but we're going, and now we have x equals a times y minus k, the quantity squared, plus h. We switch the places of the h and k because it's going sideways. The a is still 1 divided by 4 times p. Its axis is horizontal now, going straight across here, and that would be at y equals k, would be the axis.